All right, we're going to skip chapter 7. It's not one of my most favorite chapters, so we'll skip chapter 7, go do chapter 8, and then we'll come back to chapter 7, wait for it on the end. You might really like it, but it's just not my favorite thing to teach. So we're going to move to chapter 8 then, and chapter 8 is about systems of equations. So systems of equations you should have done somewhere before you got to this class. And we're specifically going to look at Gaussian elimination. And that is probably the method you used before to solve systems of equations. We've just probably never been called that before. So Gauss was a famous mathematician, and so this method is named after him, Gaussian elimination. So I'm going to remind you what a system of equations look like, and we're going to look at linear systems to start with, at least. So let's look at some linear systems. And basically, systems of equations is where you have more than one equation going on at a time. So you might see something like this: 2x minus y equals 1, and y equals 3. And to tell people that these two go together, a lot of times you're going to see the squiggly bracket holding them together. I forget the squiggly bracket very rapidly, so we might not see the squiggly bracket every time. Okay, but basically you've got two equations, but they're going together at the same time. And Gaussian elimination is where you eliminate one variable after another variable. So right now, as you can see, it's got both x's and y's in it. But if we were to use a substitution where we take this y equals 3 and stick it there, all of a sudden the y's are going to disappear. So we can use substitution to easily come up with a single equation that only has one variable. So we eliminate a variable, and that's what the Gaussian elimination says. Now from here, we can figure out what x would equal. So we'd go plus 3, so we have 2x equals 4, so x equals 2, and we also know that y was equal to 3. So when we look at a linear system of equations, what we're actually looking at is two values, two coordinates, an x and a y. And truth be told, that graphically, this is where these two lines intersect each other. So if we were to draw a little graph here, this one up here, the y equals 3, is just a horizontal line. So we've got a horizontal line going on here. And this one, if I move things around a little bit, we're going to have 2x minus 1 equals y. So there's y equals mx plus b formula. So this guy is going to go through the point -1 and then go up 2 over 1, up 2 over 1, up 2 over 1. So this line, excuse my not very linear lines, goes like that. And what we've found is at the point 2, 3, they intersect each other. So when we start looking at linear systems of equations, we're going to do it algebraically, but we can get a graphical idea of what's going on by thinking about where do these two lines intersect each other. Okay, so let's look at one a little bit bigger than that one. Again, blue and blue things around here. So let's say that we don't really need the graph, so I'll get rid of it. Let's say that we were given 3x plus 4y. Oops, my pen's starting to give up. Equals -2. And the other one is going to be -3x minus y equals 5. Now, see, right off the bat, I forget the squiggly bracket. Okay, so squiggly bracket to say that that's what we've got going on. And the Gaussian elimination, when we have both parts, so unlike this one's a little bit bigger. We've got both x's and y's. What we want to do is eliminate a variable. And we're going to do that by combining the two equations. So here we combine just by plugging this one into the top one. Here we're going to combine by adding them together. And notice what happens if we add them together. These x's are going to go away, right? 3x minus 3x is going to equal 0. And then here we're going to have 4y minus y. So that's going to be 3y equals 3. Okay. So you see how we've eliminated the x's, and that's ideally what we want to happen. And now we can find that y equals 1. Okay, we're down to a single variable, y equals 1. Only issue with these guys is that unlike this one where we already knew what y equaled, this one we need to go back into the problem and figure out what x equals. So we're going to say minus, and it doesn't matter which one you use, I just feel like that one looks a little bit simpler. So we're going to go minus 3x minus, and we're going to put in our 1, equals 5. So negative 3x equals 6. So x equals negative 2. So the point where they intersect would be the point negative 2, 1. So guys, remember how I told you a couple days ago or a couple lectures ago that there was some grunting going on in the barn, and I told you that it was a big turtle and he was waking up? Well, I wasn't kidding, and this morning he is truly awake, and so I wanted to show you Hercules. So just so you see how big Hercules is, there's my hand on Hercules. Good boy, Hercule. So Hercules is a 140-pound tortoise. So, and he's waking up for the day. He's going to go out and munch on some grass. Okay. So I wasn't lying when I told you there was a tortoise in here. This is where he sleeps during the summer. In the winter, he sleeps in the garage on his heat pad. Okay, so let's get back to this. Okay. So let's look at one a little bit more challenging than these two. Let's see what happens, what we have in the challenging section here. I don't like those. All right, let me go find one in the homework section then. Where's the homework? Come on. Come on. Well, this book just doesn't really give you anything great. How about this one? Okay, we'll work on this one. All right, so x plus 4y equals 6. So x plus 4y equals 6. And what's the other one? 1/12 x plus 1/3 y equals 1/2. Okay, there we go. Okay, so they go right from not hard to whoop, let's throw in fractions and make this challenging. Okay, so if we've got a situation like this one going on, and we want to try to use this Gaussian elimination, first thing we want to do is get rid of the fractions. And the way we can do that is just by multiplying the whole fraction, or the whole equation, by the common denominator, which would be 12. Now the top equation isn't going to change, so it's still going to have the x plus 4y equals 6. But as we multiply through by 12, the 12 will cancel here and leave us an x. It's going to cancel here, 12, and leave us a 4y. And then it's going to cancel here, and it's going to leave us a 6. Now, do you see something a little bit weird about this? Now, there is our system. Now, in this format, it might not have been easy to see, but written this way, what do we actually have? Okay, this happens to be the same line, doesn't it? So these guys end up being the same line. And what that means is if you've got one line, you've got another line sitting right on top of it. So this one actually has infinite solutions. Since they are the same line, every single value on that line is a solution. So sometimes you're gonna get something like this that pops up, okay? Not always gonna be just written like that. It's gonna be written kind of weird, and then they're going to, it's gonna pop up as you start to simplify. Okay, so we've seen a situation like that, but that still doesn't get us to helping us solve these bigger, uglier equations. So that can pop up. All right, let's see what else we've got. Okay, how about this one? Squirt, squirt. Okay, so how about 1/3 x minus 4/5 y equals 7/5? And the other one has fractions too. 2/9 x plus 1/3 y equals 1/2. Okay, these definitely are uglier looking there. Okay, so from the beginning, we have no idea what this is gonna look like once we get rid of the fractions. So that's the first thing, is to get rid of the fractions. So top equation has a common denominator of 15. So we'll multiply everybody here by 15. Bottom of the equation is kind of uglier. The 9 and the 3 are nice, but because of the 2, the common denominator here is going to be 18. Okay, so we'll rewrite 15 divided by 3 is 5x. 15 divided by 5 is 3. So with that 3, that's going to make that minus 12y. And 15 divided by 5 is 3 again, so that's going to be 21. Now, 18 divided by 9 is 2, so that's going to make that a 4. 18 divided by 3 is 6, so that'll be plus 6y. And 18 divided by 2 is just going to be 9. Okay. So now we end up with a system of equations without fractions. They're not the same line like they were over here, so we got to figure out what we're going to do. Now, if we were to combine these right now, nothing is going to go away, is it? Okay, nothing will cancel out. So we multiplied by 15 or 18 up there. We can continue to do that. Notice how this is a minus and this is a plus. If that was a 12, couldn't these guys cancel out? And yeah, they could. So guess what we can do? We can take this whole bottom equation and multiply it by a 2. If we multiply on this side and we multiply on that side, no big deal, just like we did above. So the top equation is going to stay the same. But we're going to multiply through on the bottom, so that's going to give us 8x plus 12y, and it's going to give us 18, isn't it? All right, well, this is not looking very pretty. Okay, make sure we did everything right. Okay, so now if we combine, we're going to have 13x, and 13x is going to equal, because those guys are going to go away, right? They cancel out. Is going to equal, and what do we get there? 39. Now, I know because I've been doing this a really long time, but I also know from playing cards that 39 divided by 13 is equal to 3. So we get that x is equal to 3. All right, we eliminated one variable, we found the other variable. Now, we can take that guy, and I don't want to go back here. This is too much of a mess. We can come back to any equation we want. This one, to me, seems to have the smallest numbers, so I think I would go here, but if you like that one, you can go wherever you want. So we're going to say 4 times 3 plus 6y equals 9. So 12 plus 6y equals 9. So we'll subtract the 12, so we'll have 6y equals negative 3. And divide, so y equals, if we divide, that's going to be negative 1/2. So we end up with the point 3, negative 1/2. Okay. All right, and there we go. Okay, so we've got systems of equations that we're looking at, and let's see. Let's start with that for right now, and then we'll come back and do the big guys with the 3 variables in a separate lecture. Okay, so that's the first part of 8.1. So good with 8.1 part 1.